where we have a problem to explain the data, right? When it comes to explaining the data to anyone, so we will find it very difficult, right? So not only in terms of in general or in real life, but again, when it comes to client, when it comes to project, so where we need to explain our data to the client, right? So when you are dealing with the millions of data, obvious that you will not be able to go through each and every single point. It's humanly, I mean, it's impossible, right? So that's where our visualization will help us to make a client understand or other person understand how we can explain a data perfectly without making any difficulty, right? So that is the idea behind this visualization tools and all. So in this visualization tools, we are going to talk about Matplotlib and Seaborn. So how to analyze the data? That is the main objective here. So first and foremost, let's import some libraries and try to work on one Matplotlib. So first I'm going to import a NumPy. So we'll create some data, and we know how to create the data using NumPy libraries, right? We will see that, and we'll make use of a pandas. And here I'm going to import a Seaborn, right? So import Seaborn as so SNS. So just like how we use a NP and the pandas PD. So similarly, I'm going to use a SNS. And I'm importing matplotlib.pyplot, right? Import matplotlib as an my pyplot as PLT. These are the common terms we use as a shortcut. So let's add it to the same shortcuts, all right? Then I have a percentage matplotlib inline. I will talk more about this when the time comes. Right now, do not worry about this, all right? So I will talk about it. So, and as usual, I'm importing a NumPy, some random number generation to generate our own numbers, right? So here the two things are important, matplotlib.pyplot and Seaborn. Otherwise, we know this, and we know this as well. All right. So let's execute this. So what I'm going to do, I'm going to use this random. We know what is random, right? We discussed at length in the NumPy sessions. So I'm going to use this random, and we know what is this 10 and what is 4, right? So we are going to generate 10 rows data and 4 columns, right? So rows and columns. Since we know we are generating 4 columns, I'm giving A, B, C, D because I already know it. And we are going to convert that into data frame. So these things are normal for us. So we already worked on this, and we know everything, what is random and 10,4 and all. So these are all basically what the random data generation, and this will keep changing every time. All right, now let's talk about plotting a bar. So data frame is our data frame, DF. So I'm going to say data frame, this is the data, whatever the name you use, you can use this data frame dot, I will say plot dot bar, right? So what kind of a chart it is, what kind of a graph it is, it's a bar plot. This is the name of the graph. So here, if you see that here, I'm not used a PLG nor a SNS, pyplot or a matplotlib or a Seaborn. So in the data frame, in the pandas itself, we have some plotting techniques. Right here, I have not used any of them. So pandas also giving some graph plotting techniques. So I'm using a data frame, and I'll simply say dot plot, and this is the type of a graph I want. So if I execute this, Now you can see that. So let's not worry about a -1. These are all the randomly generated data. So what we will understand here. Okay, so let's do one thing. Let's try to take this A data, right? How to identify using this color codings. So everything will be plotted within this chart itself. So you will be able to understand these numbers. And sorry, these colors. This is the A data. What does A data says? A data is say 2.95 minus 12 minus 1.248, things like that. So now the very first data is what? 2.95 positive data, right? So if you say this is the very positive, very first data, A1, so you can see 2.95. Assume that it is at 2.95. In fact is 2.95 only, so you'll not be able to see that one, but yeah. So the very first data, right? The very first data. So positive 2.95. And we have some negative numbers. If you look into the second one is of this row A minus 1.24, right? So you can see here the first one, you see this minus 1.24. So you have to understand this imaginary line. You have to just imagine that, and you have to understand what exactly could be the number, right? So that's how you can map it. So a very simple plot, and we have generated some random numbers. All right. And the same thing I can write this way. Same thing. What I did, df plot, and in the bracket you can say what type of a plot you want. So kind equal to bar, kind equal to bar, right? So same thing, it is going to give me the result. There is no change at all. Only thing is that instead of saying a dot bar, what I did, I just used the parenthesis in this bracket. I said kind equal to, in the quotes I have mentioned bar. Straightforward. There is no confusion, nothing, right? Now the same thing, df dot plot dot bar h. Bar h means what? H is simply nothing but horizontal. So these are vertical, right? All are vertical. So I can just try to plot this one. All right. So let's execute this. Same data. So the reason why I'm showing you multiple ways and all. So if you want to write this way, you can go ahead and write your choice. If you're comfortable writing this way, you can write that way. So however you feel comfortable, you can write. And visualization wise, some are basically more comfortable analyzing the data in horizontal way, right? So positive, negative. If you're very much interested in the data which is plotted horizontally, yes, you can use bar H. Right? Usually, I don't like personally, but if you are interested to plot a horizontal graph and analyze the data, yes, you can go ahead and use bar H. H is simply nothing but horizontal, right? Very simple techniques, nothing. Know this. Irish. Now, so if I go to images, you see this is a iris flower, right? So even though it looks the same, right? even though it is same, but inside iris flower itself, there are a couple of species, right? So, so if I look into this iris flower, let's take this one. So this is, you can see clearly how things are, the petals and sepals looks like. But here, what is happening? So they have different sizes, like a sepal size and a petal, right? The length of this and width of this are going to be different for different species. There are three species, three types. So those types are dependent on basically the width and the height and width of the length and width of the this sepal and petals, right? We try to understand. So there are three types of our species. Okay, these are the species: versicolor, setosa, and virginica. They all look same, but yeah, virginica. You can, if you give me a second, let me open this. If you pay close attention, right, you see this how what kind of a structure it has, and the length and the width, right? And if you look into this versicolor, this is a different one. This is a little longer and very short width. Similarly, this guy, right? So based on this height and width and the length, so these species are identified, right? We'll talk more about that. Here, I just wanted to give an idea about a iris flower, iris. So this flower data set is already available with the SNS. What is SNS? SNS is a seaborn. In the seaborn, we already have a iris flower. So I wanted to, when I say iris flower, the data of the iris flowers, iris species. So that is available inside seaborn, and I wanted to download it. How? Seaborn dot load underscore data set, right? So here I'm giving iris. The whole thing I'm loading into iris, right? There are many data sets available. We'll talk one by one, right? So let's use this head method, and you can see sepal length, sepal width, petal length, petal width, and these are the different species. There are so many rows available. Here I just printed head method, right? So you are seeing only top 5 rows, and they all belongs to setosa species, right? So yes, we'll see these are the numbers, length and width, petal length and petal length, petal length and petal width. So this is a data set. I don't want it to create just every time this one. I'm using the available data set. So how to plot, I wanted to plot some graphs using this data. So what are the different techniques again? So I'll take this iris data, sorry, dot, and sepal underscore length. I'm selecting only this column, dot plot. You see what is happening? The same concept I used, data frame dot plot dot bar, or I can also write kind equal to bar. Right? There I used a whole data frame. So here I'm selecting this particular column. That is the only difference. Otherwise, technique is exactly same. Right? So I will want to plot a graph for only this data. So let's execute this. So this is how it looks like. Right? So it will start from the lowest point. So whichever the lowest point is available in any row, it will start from there. It won't be like the very first record is 5.1. You don't see like that, right? So bar plot here, what is happening? It will sort this column, sort this, and it will start from this for it start from here and it will reach 8.0. Means this type of numbers are available in this sepal length. And what is the frequency here? What is frequency? Means how many times it is occurring. Suppose say, let's take this guy. Suppose say this is 23. Let's assume it's 23. So the data between, let's say this is 4.7 and this is up to 5. So the data between 4.7 to 5.0. So those data are occurring 23 times. How many times? 23 times. So this is how you can interpret. Well, but for me, it doesn't look that clear. So is it 4.7 or 5 or how many are there? So there is a possibility that behind this building blocks, what you see, so there could be some data behind this block also, right? Right. So it's possible. I'm not able to see it. I'm not able to judge it. So how do I identify? How do I make sure that it gives a clear picture? So what I will do, I will use the same concept, iris sepal length dot plot in the bracket kind equal to hist. This time I am going to add one new parameter called bins. So what this bins is? So let's execute this and interpret. So now you can see this bins. So clearly you can see that, okay, here we have one element or one data, right? So that is could be 4.5 and it is occurring only one time. And if you see this one, right? So it is a 7.8 maybe. So it is occurring only one time. So clear cut, I can see that. And what is this 50 bins, right? This bins basically 1. So you can see 1. So this one is whole thing is 1, right? 2. So the reason why we use this bins to spread the data properly and visualize it, right? Spreading the data and visualizing it properly. So how many times it is occurring? So 50 bins we have created. So now instead of 50, if I say 20, right? Why we need a bins parameter? If I say 20, so here I don't get much of a clear information, right? So, but if I increase this bins to 50, you can give any number, it's your choice. So it depends upon the data. So how you want to analyze, I mean, is it clear for your analysis or not? So I can also say that there is no data, there is no element available for this particular, say 5.8. There is no length at 5.8. So there is no such length available in the data set. You know, so this kind of analysis I can make it. So fine, let's try to understand this. So I don't need, suppose say that, so species, right? This is basically what, this is a object type, right? String. So for a string and all, it is difficult to plot a graph. There are different ways. We will deal that in other graphing technique. So here we don't want a species, right? So what I'm going to do, I am going to drop that. First, I don't want it. So we know how to drop the columns. So I will just run this and I will just keep that data. Right? Basically, I don't want to use the species column. That's why I have dropped it. Okay. So now I have got this data frame. I want to use some different plotting technique, right? df, I will say dot hist. Hist means histogram, Hist means histogram. And I can start coding the colors. So here I'm giving a blue. You can give red, right? So I can have my own color here. So color is one of the parameter. I'm going to give this color. If you don't give this color is also fine. By default, whatever the color is there, it is going to plot it. So here I did not give any color, right? So it has printed this color. So if you want to override it, if you want to change it, yes, we have an option to do that. I will talk about alpha and fig size, right? Just execute and we'll interpret this. I will take questions, okay? So just hang on. Now what happened here? Why we got four charts here or a graph? We need to understand one by one. First of all, let's understand fig size. Fig size is nothing but figure size here. What is 10? This is 10. This is 10 and this is 5. Sometimes it is difficult to visualize the data, right? If you think it's very small, you can increase this 15, 20. Here you can increase to 10. Right? So based on the data, based on how you want to see the data, so you can play around with these numbers. Height, length and height here. That is figure size. In this size only, I wanted to plot the graphs. And what is this alpha? This is the thickness of the color. Thickness of the color. So what I will do, I will change it to 9. It's too dark, right? Right? So if I change it to 1, it will be very light. Right? These are the extra parameters. So you can always give different based on your choice and things like that. So I will change it to red R and run it. Yeah, you can see the red color. So this plt.show is basically showing the your graphs, right? Showing these graphs. So in this size 10,5 and the thickness of the color and the color type. And what is this graph? This is a histogram. This is a histogram. So what does this tell? This tells that, so how many data points, right? This is again a frequency. So data between 2 to 2.3. So in this length, starting from 2.0 to 2.3, so there are maybe 3 data points available in this sepal. The reason why it is showing all the 4 columns, because I have selected whole data set, DF, complete data set. It has 4 columns. If you want to plot only particular column, we already did it, right? So if you don't specify any column name, yes, it will take all the columns and it will plot the graphs for each and every column. And you need to make sure all the columns are in numbers, not strings, right? How can you plot a string? Suppose say I'm writing a ABC person name, XYZ. How can I plot this? What is ABC? What is XYZ? Right? So yes, we have some other things that we will discuss. But here, when I'm plotting histogram and all, so yes, make sure that they are in the numbers. So I cannot write a XYZ and ABC. It doesn't make any sense.